MATLAB has great graphical capabilities. We're going to start off taking a look at a simple yet very effective type of graph called a line graph. Line graphs are very useful for graphing functions. They're also great for showing how data changes over time, taking a look at trends in data, and they're good for showing how one variable depends on another. The MATLAB command for creating a line graph is plot. The general form is just to type the key command plot. The first argument in the plot function is the x-coordinates of the points that you would like to plot. The second argument is the y-coordinates of the points that you would like to plot. And the third argument is any optional formatting. We'll see a little later on in this video that we can also plot multiple functions on the same plot. So here we have a simple example. We have our key command plot. The first argument in the plot command is the x-coordinates of the points, and I have one x-coordinate, x equals 3. The next argument is the y-coordinates. Again, one y-coordinate, y is equal to 4. If you're plotting points, of course, the number of x-coordinates and the number of y-coordinates better be exactly the same. Finally, the third argument is formatting, and the R here means red. The star means that I want my data point to appear as an asterisk. So if I were to run this command in MATLAB, that's what I get, a point at 3, 4, and it's a red star. So let's look at a slightly more complicated example. Again, I have my plot command. The first argument in the plot command is the x-coordinates of the points that I would like to plot. And in this case, you can see that I'm going to plot 3 points. And the way that I enter those x-coordinates when I have multiple points is I have to enter them in as a vector or a one-dimensional array. So I have my square brackets, and then I have the x-coordinates of the points that I would like to plot separated by some white space. I have a corresponding set of y-coordinates, 3 y-coordinates, also entered in as a vector, and if I run this command in MATLAB, I get 3 points. Notice that my points are automatically connected by lines, and those lines are blue. That's the default format. MATLAB will connect your points and it'll connect it with blue lines. So let's talk a little bit about formatting. We have lots of different options for how we want our graphs to look. We can pick color, we can pick how we want the data points to appear, we can pick whether we want those data points to be connected by solid lines, dotted lines, or if we don't want them to be connected at all. I've copied this little table of options. If you want to reproduce this table in MATLAB, you simply type help plot at the command line. There's a lot of information there. Scroll way up and you'll find this exact table that I've put here for reference. So if we look at that same command that we just ran to plot those 3 points, and we add that optional third formatting thing, I can see I have RD double dash, and that means I want a red line, I want my data points marked as diamonds, and I want them connected with a double dash. Another option, same 3 points. This time my color is K, which is black. B actually is for blue. S means that I want squares for my data points, and a single dash means that I want a solid line connecting those data points. Now we're going to take a look at graphing functions. So we want to graph this polynomial function. Y is t cubed minus 6t squared plus 3t plus 10. Very first thing I'm going to do is generate a vector of the x-coordinates of the points, and then I'm going to plug those x-coordinates into the equation to generate a vector of y-coordinates. We have several different methods that we learned in the previous video for generating a vector of points. First thing I can do is enter all the points in. So I have t equals, square brackets, type in whatever values I want. Works great if you only have a few t values, not so good if you want to plot a lot of values. My second option was the start increment max option. So here I'm going to start t at minus 2, I'm going to increment by 0.01, and I'm going to quit before I exceed 7. And in this case, I will get a vector of 901 t values from minus 2 to 7 incremented by 0.01. Another option, linspace command. First argument in linspace is my starter point, so t will start at -2. Second argument is my ending point, so t will end at 7. Third argument is how many points I want between -2 and 7, and in this case I want 500 points. So I have several options for creating the x coordinates of my points. I'm going with the second option. So now I have the x coordinates of my points. In order to get the y coordinates of the points, I have to plug each of those t values into my equation for y. And we know how to do that. This is the MATLAB command that I would use to plug each t value into the equation for y and generate the corresponding set of y values. What's the deal with the t dot hat cubed and the t dot hat squared? You already know the answer to this from the previous video. I want MATLAB to go into that t vector and I want it to cube each of those values individually, or I want it to square each of those values individually, and I need to use the entry by entry operator in order to accomplish this. So now I have the values that I want to go on my x-axis. They're stored in a vector called t. I have the values that I want to go on the y-axis. They're stored in a vector called y. So I'm ready to plot. Plot t comma y, and I get this polynomial curve. When you're graphing functions, you want to get in the habit of labeling the x-axis, the y-axis, and adding a title so you know what it is you're looking at. How do you label the x-axis? Very easy. I use the command xlabel, and then in parentheses I put a string that I want to appear in the label. So I have in single quotes time comma t, and that will appear as my x label. How do I label the y-axis? Y label. How do I add a title? Title. And in each of those commands I simply put a string inside the parentheses describing what I want to appear where. If you want to add a grid to your plot, very easy, the command is grid. MATLAB has a really nice GUI called Plot Tools that allows you to do this interactively, add labels, change axis size, change colors, all this kind of stuff, rather than doing it with MATLAB commands. To get Plot Tools started, you just click on the little icon you can see there in the diagram, and Plot Tools is something that will be demonstrated in lecture. There are a couple of common errors that people typically make when they're learning how to plot, and these revolve around choosing the x-axis values poorly. So we're going to plot the exact same polynomial that we just plotted before. However, I'm going to choose the x-axis values differently. My vector t of x coordinates is going to start at -2. It's not going to exceed 7, but my spacing is going to increase dramatically. My points are going to be spaced apart by 1.5 instead of 0.01, and you can see the effect on the plot. Those x coordinates are spaced so far apart, and we know that the data points are going to get connected by straight lines, so I get this very choppy looking plot instead of the nice curve that I would expect with a polynomial. Here's another example. This time I'm going to use that nice fine increment that I used the first time of 0.01. I'm going to start at -2, but I'm going to extend my graph all the way out to 100. And what happens in this case is all the fine detail in my plot basically gets compressed or squashed out. Because if you go all the way out to t equal to 100 and you plug that into that polynomial equation, the y value at t equal to 100 is close to 1,000,000. So all the fine detail in the plot disappears. How do you know how to pick the x-axis values? A lot of times you're just going to have to experiment. See what the plot looks like, change your values, change your increment, change your range, and see how your plot changes and decide based on that. I can put multiple functions on one plot. Let's take a look at putting these 3 exponential functions in a single plot window. Step 1, create a vector of points to go on the x-axis. So I'm going to call my vector t. I'm going to start it at 0, I'm going to end at 5, and I'm going to increment by 0.01. How did I choose an ending point of 5 seconds? Well, I know that e to the -5 is a really small number, And if I look at these exponential functions at time equal 5, the first one will be at e to the minus 5, the next one will be at e to the minus 10, the third one will be at e to the minus 20, all very, very small numbers. Step 2, calculate the y-coordinates by plugging the t-values into each of the three functions. Note that in MATLAB, the exponential function is exp. Do not use e. Step 3, use the plot command. Alright, so now we've got three functions that we need to plot, but we can do this within a single plot command. So we simply have plot. Where are the x-coordinates for our first function? They're stored in our vector t. What are our y-coordinates? The points stored in the vector f1. What are the x-coordinates of the second function? The vector t. Y-coordinates are stored in the vector f2. And finally, for the third function, the x-coordinates are stored in the vector t, and the y-coordinates are stored in the vector f3. And if I run this plot statement, I get a plot. Now you can see I've got three functions in the same plot window, and it automatically colors those three functions differently. But I really need a legend added to this plot to make that very clear, so let's go ahead and add a legend. So the legend command in MATLAB is legend, and inside the legend function I have to add a string for each one of the functions that I have plotted that describes what that function is. So if I run that command, I can see that I now have a legend added to this plot. I should also add an X label of time, a title, but we already know how to do that. The last plotting command we're going to talk about is subplot. And what subplot does is it takes a figure window and it breaks it up into several sub-windows, and then you can put different plots in different sub-windows. Subplot has three input arguments. The first input argument says how many rows you want the figure window to be broken up into. The second input argument says how many columns you want the figure window broken up into. And then the last argument points to a particular subwindow. So, for example, if we had subplot 3, 2, 1, that would mean take that figure window, divide it up into 3 rows, 2 columns, and the third argument of 1 would then point to the top left subwindow. And you can see on the diagram I have put exactly how you point to each of the subwindows for this particular case. So now let's look at an example of this. Let's say I have these three functions and I want to plot them in the same figure window, but I want them to be in their own subwindow. To do this, my first step, as always, is to figure out what I want the x-coordinates of my data points to be, and I'm going to store those x-coordinates in a vector called t. Next, I'm going to take each of those x-coordinates and I'm going to plug them into my various functions in order to calculate the corresponding y-coordinates. So I've defined my set of x-coordinates, stored them in a vector called t. I've plugged those values into each of my three functions, and I'm ready to plot. If I want to put each of these functions into separate subwindows, I first need to use the subplot command. And what I'm going to do is I'm going to break up my figure window into 1 row, 3 columns, and then I'm going to point to the leftmost subwindow, and that's where I'm going to put my plot for F1. Alright, so if I execute that, then I can see that my figure window is broken up. You can kind of see how it's proportioned out, but I don't have a plot yet. So this is a two-step process. First, I use the subplot command to break up that figure window and point to where I want to plug that plot in. Then I must follow up with a plot command to actually put the graph of the function in that subwindow. So let's go ahead and do that. So I'm going to just go ahead and do plot t, f1. And if I do that and I find my figure window, now you can see that I've got a plot of the figure in that window. Alright, at this point I should go ahead and add a title to that. I should add labels, but I'm going to skip that because we've already talked about the X label and the title command. So how do I get the next figure in? Well, I need to first use the subplot command to point to the next subwindow. If I forget to do that, and I would just do plot t, f2, it's going to go into that first subwindow and I'm going to lose my first function. So a two-step process again. I'm going to do subplot first. That says point to that second subwindow, and then I'm going to put my second function in there by following up with a plot statement. And if I take a look at that, sure enough, now I've got my second function plotted. And finally, I'm going to point to the last subwindow by saying subplot 1, 3, 3, and then I'm going to plot that third function. And again, anytime you're graphing, you're going to want to add labels on the x-axis. You're going to want to add titles using the x label and the title commands. So here's a summary of some of the basic plotting commands that we've talked about. And here's some others that you might find useful. You can close a figure window, or you can create a new figure window. The axis command and xlim and ylim allow you to adjust the scale on the various axes. Hold on allows you to keep what is currently plotted in your figure window and add more things to that plot. Practice time. Try each of these commands in MATLAB and make sure that you understand what these commands are doing, and then return to the video to take the quiz.